Hey guys, welcome to Lesson 7, Unit Rate and the Constant of Proportionality. All right, let's get started with our first example. So, wildlife conservationists are concerned that the deer population might not be constant across the national forest. The scientists found that there are 144 deer in a 16 square mile area of the forest. In another part of the forest, conservationists counted 107. Okay, these look like ratios. We better write them down. Okay, so let's make a little ratio table real quick. So this is going to be miles, and this is going to be, this is not hashtag deer. This is the number of deer. Okay, miles of deer. So, or not miles of deer, but so this is 16 square miles. Okay. So this little 2 is because I'm writing miles squared because it's square miles, right? So a square mile is like, you guys know area. So a square mile is a 1 mile by 1 mile square. So in a 16 square mile section of forest, there were 144 deer. In a 13 square mile, there was 117 deer, and in yet a third, a conservationist counted 216 deer in a 24 square mile plot of forest. Okay, so where did I get these numbers from? I read the problem. The scientists found that there were 144 deer in a 16 square mile area of the forest. And in another part of the forest, conservationists counted 117 deer in a 13 square mile area. Yet a third conservationist counted 216 deer in a 24 square mile plot of forest. Do the conservationists need to be worried? Well, let's figure that out, and the constant of proportionality is going to help us. Okay, so why does it matter if the deer population is not consistent in a certain area of the national park? So this isn't necessarily a math problem, but it's still important. So if all of the deer, like I'm gonna draw this super realistic picture, super realistic picture of a forest, right? Here's my trees, and this tree represents all the trees in the forest. Now let's say all of the deers, like let's imagine this is huge. It's like a 1,000 by 10 miles, which is crazy huge, right? Now let's say all of the deer lived here. This is where all the deer lived. This would be really bad because deer are an important part of an ecosystem, and if there weren't deer everywhere else and they were all here, they would probably eat all the food. So, or they could like hurt each other. I don't know. But there's lots of reasons why it would be important that the deer were spread out. Okay, so what is the population density of deer per square mile? So basically that's asking us to find the constant of proportionality. And the way we do that is by taking this thing and turning it into a fraction. And we're going to do this. We're going to put the bigger number on top, 144 over 16. And we need to figure out what this is equal to. Well, this is just a division problem, so let's do it. 16, 144. 16 doesn't go into, let me write that better. 16 doesn't go into 14. But 16 does go into 144 9 times. Okay, 16 times 9 is 144. So this equals 9. Okay, now let's do 117 divided by 13. I think this one is also 9. 9 times 3 is 27. 9, 10, 11, yep, 9. So the constant here is 9. Okay, and then, anybody want to guess? 216 divided by 24. Let's try 9 out. 9 times 4 is 36. 18, 19, 20, 21. Okay, 9. So the constant of proportionality here, so this is the constant of the constant of proportionality is 9. So basically, however many square miles we have, if we multiply that by 9, it should give us an estimate of deer. So for example, if we had 1 square mile, there would be 9 deers, and the constant of proportionality would be 9. If there were 2 square miles, 18 deer. Constant of proportionality is 9. So this is important because it kind of lets us know, like, hey, these ratios are equivalent, and it lets us know how to go from one set of values to another. So let's move on with the question. And it says, the unit rate of deer per 1 square mile is, 9. So in 1 square mile, there are 9 deers. And the constant of proportionality is 9. Explain the meaning of the constant of proportionality in this problem. So we kind of did that. It basically just means in 1 square mile, there are 9 deer. C. Using the unit rate of deer per square mile, or y over x. So in this table, if we treat this as x and we treat this as y, all of our numbers would be y over x. I don't know why I write my y's two different ways, but I do. Okay, so using the unit rate of deer per square mile, or y over x, and in this problem this equals 9, to determine how many deer there are for every 207 square miles. So remember in our table, x was miles, so we need to figure out how many deer there are. So we're going to do 207 times 9. And I'm going to do that over here where I actually have space. 207 times 9. 9 times 7 is definitely not 30. It's 63, 15, 18, 19. So in 207 square miles, there's 1,953 deer. Use the unit rate to determine the number of square miles in which you would find 486 deer. Okay. I guess let me go back real quick. So another way we could have set this up is we know that we have y over 207 and that this equals 9. And that lets me know, like, if I want to solve for this y here, this variable, I can multiply both sides by 207. So we can do that kind of same thing. So remember, y is the number of deer, and we got that from our previous table that we made. So this is going to be y, which is the number of deer, over x, and this equals 9. So we need to figure out what this number is. So 486 over some number equals 9. So what we can do is take 486 and divide it by 9. 9 goes into 48 5 times. 45, 36, 9 times 4 is 36. So x is going to equal 54. In 54 square miles, there are 486 deer. So let's do example 2, French cooking class. Suzette and Margot want to prepare crepes for all of the students in their French class. A recipe makes 20 crepes with a certain amount of flour, milk, and 2 eggs. The girls already know that they have plenty of flour and milk to make 50 crepes, but they need to decide the number of eggs. They need to determine the number of eggs they will need for the recipe because they're not sure they have enough. Considering the amount of eggs necessary to make the crepes, what is the constant of proportionality? All right, so let's set this up. They know they have enough flour and milk, but they're not sure about eggs. Okay, so, and this is crepes. Okay, and I'm gonna put the little fancy, whatever that's called. All right, so a recipe makes 20 crepes. Okay, 20 crepes. And they need some amount of flour, some amount of eggs. Okay, but they need 2 eggs, so that some amount is 2. All right, cool. So they need to determine how many eggs they need to make 50 crepes. So what we want to do is we're trying to figure out 50. And we need to figure out the constant of proportionality. So basically we need to take one of these numbers and make it 1. So we're going to take this number and we're going to make it 1. And we're doing that by dividing by 2. So 2 divided by 2 is 1. 20 divided by 2 is 10. So just like we did in the other problem, right? This is like our x and this is our y. We can find our constant of proportionality by putting y over x. So if we do that here, what we get is, well, y is equal to 2 over 10. Over 20. I'm just copying the numbers from here, right? This is our x column. This is our y column. So if we put y over x, we get 2 over 10, which is 1/10. Right? If we do the same thing here with our unit ratio, our constant of proportionality here was 2 over 20, which equals 1/10. Here it's just straight up 1/10. And here we have some number over 50. We need to figure out what number goes in here. Well, this isn't too bad because we already have our unit ratio here, our unit rate here. We know that 10 times 5 is 50, so this number is going to be 5. Right? We get 5 over 50. So how many eggs do we need to make 50 crepes? 5. Considering the amount of eggs necessary to make the crepes, what is the constant of proportionality? The constant of proportionality is 1/10. So we need 1/10 the number of eggs for crepes. So if you take 20 and you multiply it by 1/10, you get 2. What does the constant of proportionality mean in the context of this problem? It means that 1 egg makes 10 crepes. Okay, how many eggs are needed to make 50 crepes? 5. Let me do number 1 on this problem set. For each of the following problems, define the constant of proportionality to answer the follow-up question. Bananas are 59 cents a pound. I don't like bananas, but that's fine. I can still do math with them. So here is the cost, and here is the pounds. I'll just call them banana pounds. Banana pounds. Whoops. Okay, so banana pounds are 59 cents. Oops, sorry. 1 pound of bananas are 59 cents. Okay, so bananas for 1 pound, 59 cents. For 2 pounds, $1.18, right? That's 59 plus 59. And 1, 8, 10, 11. That's more, yeah, okay, 118. So bananas, $1 is 59 cents. $2, 1 over 18. So remember, we do for our constant of proportionality, what we've been doing is y over x. Well, here in this case, y over x is going to equal 0.59. And if I did the same thing here, if I took 1.18 over 2, 1.18, that's like my y, over my x, 2, this is going to equal 59 cents. So the constant of proportionality is 59 cents. How much will 25 pounds of bananas cost? Okay, I'm going to take 25 pounds, my x, and I'm going to multiply it by my constant of proportionality, 59. All right, so let's do this. 25 times 59. Okay. That's definitely a 9. 9 times 5, 45. 9 times 2 is 18, 19, 20, 21, 22. Okay, I bring down my 0. 5 times 5 is 25. 10, 11, 12. Add these things up. 5, 7, 4, 1. I've got 2 decimal places, so that thing goes right there. 14.75 is how much 25 pounds of banana cost. So I could also do this by setting up an equation, which were in those notes that you took, right? So y is going to equal x times k. So x is the numbers in this column, y is the numbers in this column, and k is our constant of proportionality. So in this instance, we would have, you could have like 118, right, equals 2 times 0.59. This is our y value, our x value, and our constant of proportionality. Okay, bye.